Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. Today we're going to be solving a killer Sudoku called Peer Pressure by Philip Newman. It was originally posted in GAS on February 26th, 2025. So in Killer Sudoku, we have standard Sudoku rules, so we're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And then there are also some cages in the grid, and cages, digits can't repeat in a cage. Here it's kind of irrelevant because every cage is fully contained within a region. But on top of that, there's a clue in the top left corner of each cage, and that tells you the sum of the digits that are in that cage. So we're going to start here. 10 is the lowest possible sum we can have for 4 digits. That's 1, 2, 3, and 4. And then 11 is the second lowest possible sum. That's going to be 1, 2, 3, and 5. So now 1, 2, and 3 can't appear in any of these cells, so they have to appear over here in order to go anywhere in row 3. We're going to leave that for just a moment. Also note that because 5 is used here, there are only 2 ways to make 14 in 2 cells. There's either 5 plus 9 or 6 plus 8, so we're going to do 6 plus 8 there because 5 is already used in this cage. So let's take a look at this 22 because this is a little bit suspicious to me. So the biggest that these two numbers can be is 2 and 3, which is 5. And so if we have 5 here, what do we have left over in the 22 cage? 22 minus 5 is 17. And 17 happens to be the largest possible sum of 2 digits in Sudoku. That is 8 plus 9. So that does in fact have to be 2 plus 3 and 8 plus 9, which makes that a 6 and makes this an 8. And I know my 6 is going to be over here. So what else can we do from this? So 28, that does have to have an 8 and a 9 in it, I believe, because if it didn't have a 9, then the biggest it could possibly be would be 5, 6, 7, and 8, which is 26. If it didn't have an 8 in it, the biggest it could be would be 5, 6, 7, and 9, which is 27. So it does have an 8 and a 9. And so 8 and 9 would go over here. I don't think I'm actually going to need that. 30 is always 6, 7, 8, and 9. 29 is always 5, 7, 8, and 9, so 7, 8, and 9 are going to go over here. The lowest these two cells can now be is 7 and 8, making these 1 and 2. So this is going to be a 9. And now the 6 can't be 1 and 5 because there's a 5 in the region already, so that's going to be 2 and 4. The 4 will go there and the 2 will go there because of the 1, 2 pair. Let's focus for a moment on this middle region. So this is going to be 1 and 2, because 3 is always 1 and 2. Then my smallest remaining digits are 3 and 4, which will have to go here. My biggest digits are 8 and 9. And my next biggest remaining digits are 6 and 7, which will go there and there. Now I can't have a 7 or 8 in these cells, so that'll be 5 and 9. And I can eliminate 5 and 9 from those cells. And I can't have a 2 or 3 in these cells, those are used in the column. And so I can eliminate 2 and 3. So those will be 2 and 3. I can eliminate 2 and 3 from here and here. Now, what do I need in this column? I need a 6 and a 7, and 6 is already used in this region, so I'm going to place a 6 and a 7. And in this column, I'm going to need a 3 and a 4, and I can place them like that. And I need a 9 here. My last digit in this region is a 5, and my last digit here is going to be a 1. Okay, now if I look at this row, I still need 2, 4, and 5 here. And in this row, I still need 6, 8, and 5. And that should give me pairs here and here. Yeah, that'll give me a 1, 3 pair to finish off this region. So it's going to be 2 and 3. And a 7, 9 pair to finish off this region. So that is going to be 8 and 7. And actually, I can resolve those because this 1, 2 pair tells me that this is not a 1, it's a 3. And this 8, 9 pair tells me this is not a 9, it is in fact a 7. Now, what do I still need here? So I need to finish off this region. And those will be 4, 5, 6, and 7. And that doesn't seem likely to do anything for me just yet, so I'm just gonna leave that for now. I'm gonna pencil mark these, but then I'm gonna kind of leave them be. That can't be 3 or 4, that can be 6 or 7. I might as well clean that one up. So 15 over here is either 6 and 9 or 7 and 8. This cell can't be 7, 8, or 9 because those are taken in the column. So that'll be a 6. So this can't be 6 or 8, so that's a 5. And therefore this is now a 9, and 9 can't go there. So that is something kind of fun, because there are 2 ways to make a sum of 12 and 4. One of them is 1, 2, 3, and 6, which we've just eliminated because we've just placed a 6 in the region. So the other one has to be the correct one. It is 1, 2, 4, and 5. There's a 5 there, so these can't be 5. So we have a 1, 2, 4 triple. And our last possible digit there is a 3. And then there's going to be a 5 over here. That can't be 5. Not sure. Oh, I have 1, 2, 3, 4, and 5 taken here. So that's going to be a 6. That'll be an 8. And that takes care of the rest of the outie digits in that region. Now these guys are going to be 3, 8, and 9, and that's not a 3. And that's all that I can do for right now. Okay, in this row, those can't be 6, so I have 7, 8, and 9, so that's a 5 and that's a 9. And, okay, 5 is either 1 and 4 or 2 and 3. Can't be 2 and 3 because this digit can be neither of them, so it is 1 and 4 like this. That makes that a 5. And that's not a 5 or a 4. And so now we're doing 28 with no 4 in it. That leaves only one possible way to make 28. 5, 6, 8, and 9. That can't be 6 or 9, so that's 5 and 8. Oh, 9 is not one of my remaining digits there. That's going to be 3, 7, and 8, actually. Okay, hopefully that's fairly harmless. So I can eliminate 5 and 8 from here. That resolves this. Oh, and also I can eliminate 1 and 4 over here. And that's going to resolve a fair bit over on this side of the grid. That'll make that a 2 and a 1, and now we have our central region completely finished. That can't be an 8. In the middle here, I need 2, 3, and 7. That's going to resolve this pair. I can eliminate 7 from these cells and from this cell, and that also can't be a 4 because there's a 4 in the column. Okay, 5 and a 1. And we're very, very nearly finished. There's a 5 in this column. It's a little bit of a tricky one. I expect that the hat times are relatively long for this. So I hope you enjoyed having something to kind of sink your teeth into today. I definitely did. And we're just finishing up with some classic Sudoku. This can't be 3 or 4. There we go. And that is how you solve Philip Newman's Pure Pressure. Hope you enjoyed that. Solve it yourself using the link in the description below this video, and I will see you again in 3 days.